Welcome to Selecting Subsets of Data, the second course in the Master Data Analysis with Python series. If you have not already done so, you need to take the first course, which is titled Intro to Pandas. If you have not taken that course, then you need to stop this video, go take that course, and then come back and complete Selecting Subsets of Data. There's a lot more information on how to get everything set up, how to get introduced to Jupyter Notebooks, how to go through the material, and so forth. So go ahead and look for that course. It's titled Master Data Analysis with Python dash Intro to Pandas 2022. Make sure you look for that 2022. There's an older version of that course. Do not use it. Make sure to use the updated version that labels 2022. And here's the rest of the courses in the Master Data Analysis with Python series. You can see we're right here at selecting subsets of data. This is a very thorough and comprehensive path so that you can master using pandas to do data analysis and become an expert. Welcome to downloading the course material. If you're watching this video, then you should be on this page. Now, if you've already taken Intro to Pandas, which everyone should do as that is the precursor to this course, then you already have all of the material and you can skip the rest of the video. For everyone else, you'll need to download this zip file, which you can find in this resources section, and then click the link over here. And I'll momentarily just place it on my desktop. So once you have the zip file, just go ahead and unzip it. This will be the full contents of the course. And then I suggest creating another folder if you're going to be taking multiple courses from me, such as Dunder Data Courses, and then just drop the course material into here. So this has this contains all of the contents for both Intro to Pandas and selecting subsets of data. And if you look over here, we're primarily going to be working through the Jupyter Notebooks over here in section number 2 for this course. So that's it for downloading the course material. In this video, I'll be discussing how to go through the course material. So in this video, I'll be discussing how to go through the course material. Again, this was covered in great detail in the Intro to Pandas course, but I'll do a little summary here. So that once that we've downloaded our material and moved it into the Dunder Data Courses directory, we can then open up a terminal or a Anaconda prompt if you're on Windows and run the command Jupyter space notebook. This will launch a Jupyter Notebook. All of our material is covered inside of Jupyter Notebooks. That's where I will be coding and where you will be going through the material. So I'm going to click on Dunder Data Courses. That's where I dropped all the course material, and then Master Data Analysis with Python. It does say Intro to Pandas, but it has both Intro to Pandas and selecting subsets of data in it. So the notebooks are in the Jupyter Notebooks directory. Let's click there. We're now in section 2, selecting subsets of data, and we're going to cover all 9 of these notebooks, beginning with the first one. So you'll know I'm in a new notebook in the videos. They're divided by sections, and I'll be saying open up notebook number 1 or 2 or so forth. Let's begin by opening up notebook number 1. That's where we will be starting. And you can see here's the course material. And the way the notebooks work are such that you can read the text and then you have to execute the code to see what is displayed. The code cells are not executed by default. You'll have to do that. And at the end of the notebooks, you will have exercises to complete. Solutions for the exercises are in this solutions notebook. And one thing you'll notice during the videos is that my notebooks look different, or the notebooks in the videos look different than your notebooks. That's because a lot of the text and code have been removed. These will be shells of the actual notebooks, and that's so that you can just focus in on what's most important, which is just the code and some of the notes during the videos. You won't have to be trying to read the text while I'm going through the notebooks. All right, so that is how we're going to go through the course material. Just a quick note on exercise solution videos. There are exercises available at the end of each chapter, and videos were produced for all those exercises, but unfortunately I'm unable to include all of these exercise solution videos because of Udemy's 2-hour limit on free classes. So you'll notice that some of the later chapters do not include these exercise solution videos, but there still will be solutions in the Jupyter Notebooks, so you can get them. There just won't be videos of me completing them. Welcome everyone to a new part of the course, Selecting Subsets of Data. This is notebook number 1, Selecting Subsets of Data from Data Frames with just the brackets. So in this part of the course, we're going to begin with a data frame, and we're going to select some columns from it, or some rows, or simultaneously some rows and columns. We're not going to change the data in any way. We're just going to select them and then return a resulting data frame. So here are a few examples of subsets of data. Here we're going to just select a subset of columns. So over here is our starting data frame. The selected columns are in yellow, and over here is the result, a 3-column data frame with all of the rows. Over here, we're going to select rows. We're selecting 2 rows from that same data frame, which results in a 2-row data frame with all of the columns. We can also do simultaneous row and column selection. And here we're selecting those same 2 rows and 3 columns from above, which results in a smaller 2-row by 3-column data frame. So we're going to be practicing all different sorts of subset selection in this part of the course. Now, what's important to know with pandas is that you can select, there's dual references for selecting rows and columns. You can do so by either label or by integer location. So you can reference each row and each column by either its label or its integer location. So we'll talk a lot more about this in future videos, but this is good to keep in mind that there is this dual reference. This is actually what makes pandas quite confusing, is that you have 2 possibilities to select rows and columns. You can either use that integer location or the actual label that you see. Now, we'll be covering 3 different what are called indexers on how to select rows and columns. So the first one will just be these square brackets. That's what this notebook is about, just these brackets. We'll also learn about the loc indexer and then the iloc indexer. So the loc indexer is selection just by label. Iloc is by integer location. That's what iloc stands for. And the syntax will look something like this. So for just the brackets, we'll have df and then just square brackets appended to it. The selection will go inside of the brackets. I left that out because we don't have a specific selection here, but this is the generic syntax. For selection by label only, we'll use df.loc with square brackets appended to it. And then for integer location, it'll be df.iloc, and again with some square brackets. So this video just sets us up for the subset selection to come. We will read in a data frame and go from there. One thing to notice is that we're using square brackets here and not parentheses. So these are not methods that you call with parentheses. These are square brackets that we append to our data frame or one of the other indexers. In this video, we'll be selecting with just the brackets. So first we need some data. We're going to read in this sample data set and place the first column into the index. Let's go ahead and do that. So here we have this name column and it's in the index, so they act as labels. Each one of these strings identifies and references all the values in that row, just like all of these strings over here references all of the column values. Okay, so we first learned how to select a single column of data, which will result in a series using just the brackets. So let's go ahead and do that again. We can select this column age, which creates a series. Notice that the index comes along with it and identifies all of the values. Now, if we want to select multiple columns, we have to do so with a list. So let me just show you the incorrect way of doing this. This is a common mistake. I sometimes still do this when I'm going fast. So say I want to select
a couple of columns here, like age and height. If I do this, I'm going to get an error. This is not the correct way to select multiple columns. In order to do that, we need to create an inner list. And this is a little bit difficult to see, and it's a little tricky, and I'm going to cover it a little bit more detail below. But as you can, if you can see closely, this inner set of brackets creates a list, and this is the correct way on how to select columns. And notice what's returned is a data frame and not a series anymore. So if we selected 2 columns or 3, then we have a data frame and not a series. We can select any number of columns. The order doesn't matter. It doesn't have to be in the order that you see. What will be returned is the exact order that you put your columns in, like this. So here I've created a 3-column data frame and selects all of the rows by default. Okay, so a little more explanation on the inner setup, the inner square brackets versus the outer square brackets. So they are the same exact piece of syntax, same characters that you type on the screen. They're both square brackets, but they have a completely different meaning. So the inner set of square brackets defines a Python list. The outer set of square brackets over here in green represent subset selection. So when square brackets are appended directly to a variable name, and in this case our variable name is a data frame, it means, hey, I want to select some subset here. And if you pass in a list, which is what the inner square brackets are, it'll select those columns in that order as a data frame. All right, so hopefully that clears it up. Sometimes to make it extra clear, what I will do is I will use the call. I'll create a variable called calls, and let's just use the same ones that are in the image. So I'll definitely create a list. It's a little bit easier to see here. And then we'll still use the square brackets, which represent column selection. And I'll pass in the list, which is now called calls, like that, to make the selection. So that's another way of doing it. There's nothing wrong with doing it this way. It makes it very clear, so you don't get confused with these double square brackets. That's what really confuses people. Like, why are there 2 sets of square brackets here? Well, one is for the list and the other is for subset selection. Okay, so we already covered that. You can put columns in any order that you want. And so that is the main usage for just the brackets. That's the terminology I use to differentiate between loc and iloc indexers. I like this term, just the brackets. So there's no other indexer like .loc square brackets, .iloc square brackets. It's just df square brackets. And the primary purpose is either to select a single column or multiple columns like this. You can also do Boolean selection, and we will cover that in a later chapter. In this video, I'll complete the exercises at the bottom of the first notebook. So I'm going to read in the movie data set first before we do the exercises. So here's the movie data set. We put the title into the index. Okay, so exercise 1, it says select the column with the director's name as a series. Let's just copy and paste that. We'll just place it in there like that. So that's all we need to do. Exercise 2, select the column with the director's name and number of Facebook likes. So we're going to select 2 columns, which means we need to pass in a list. And the number of Facebook likes, that's going to be director FB, like this. So there we go. And that's how we select them. Notice that this is now a data frame that has been returned, all rows and just 2 of the columns. Exercise 3. Select a single column as a data frame and not a series. Okay, so that is a little tricky. Let's go ahead and just remain with this director Facebook. Not DF, we need movie, sorry. Okay, so how can you select this as a data frame? By default, it selects it as a series. So you have to be a little tricky here. You can create a 1 item list, and pandas will return a data frame here. So this looks really funny. There's usually you don't create 1 item lists, but this is in fact a 1 item list. And if I execute this, it will return it as a data frame. Notice how the display is completely different. A one column data frame is different than a series. This is technically 2 dimensions. You can see here 4900 by 1. A series would just be 4900 values. So you can think of like a one versus 2 dimensional array, where the 2 dimensional array is just has a single column. It's the same exact thing with data frames. All right, let's move on down here. Look in the data folder and read in another data set. Select some columns from it. All right, so the data folder is one level up. We can actually use a shell command here, like this. This is not Python code, but if you start off your line of code with an exclamation point, you will get able to use shell commands. So let's go ahead and look at this. So we can look at the Airbnb data set. So we'll just say air, we'll just read this in, and read in this Airbnb data set. And here's the first 5 rows. So again, it's the same syntax. We just take the data frame name, append just the brackets, and if you want to select one column, let's just do bedrooms, we can get that. If you want to select multiple columns, and we just use a list. So let's do bedrooms and price and say superhost, and we'll get a 3-column data frame. It's a good idea to put .head after here so we don't have to see all of the output. Okay, so that does it for the exercises. Welcome to notebook number 2, selecting subsets of data from data frames with the loc indexer. So we're going to learn a different type of subset selection. This loc indexer has different rules than the square brackets. So you have to forget about the square brackets for a moment and think of this as a new tool that has its own rules for subset selection. There will be square brackets appended to it always, but they have their own rules, and it's distinct from these square brackets that are immediately appended to the data frame. So your syntax when using loc is going to look something like this. The loc indexer is able to simultaneously select rows and columns, so which the square brackets itself is not able to do. Okay, so let's take a look at the generic syntax. It's going to look like this. df.loc square brackets, then you have the row selection, comma is very important, the column selection. So rows and cols will just be variables that you define. You can also just put your selection right there without putting any variables whatsoever. But this is your generic syntax. This is very important to understand what it is going to look like. Okay, so the loc indexer primarily selects by label. That's the other big component here. And we'll learn about iloc, which primarily selects by integer location. So the loc indexer also can select by Boolean selection, but we're going to learn about that in a later chapter. Right now we're going to focus on how it selects by label. All right, so let's go ahead and get started. Read in our data frame. We're going to put, again, this is important here, we're putting the first column into the index. The reason we're doing that is that we have a little bit more of an interesting index, and it turns them into labels. Okay, so in order to, let's complete this task, select 2 rows and 3 columns with loc. So you can do this in one line of code, but when I first start teaching this, I really like to separate out the row selection and the column selection. So for rows, we'll just pick 2 of these rows, and we can put them in a different order. So say Dean and Nico. And for calls, it says let's do 3 columns. So we can do state, food, and score like that. So when we're doing multiple rows and columns, we need to use a list. That's one of the rules here. You can use a single value. We'll talk about that in a second. But when we're doing multiple, we need a list. So we create 2 lists. We do df.loc, append the square brackets to loc, and then we just pass in rows, comma, calls. So rows is just this 2-item list. Calls is this 3-item list. We execute that, and we get our selection. So we go from this larger data frame down to just 2 rows and 3 columns. This is a new data frame. And before I forget, Whenever you make a selection like this creates a new data frame. It does not change the original data frame. So the original data frame is still df. This creates a copy that you would have to assign a new variable to in order to reference it later. So if you wanted to reference this later, you have to do some sort of assignment statement, and then you would have it stored in memory safely. So df is still going to be df after a selection. All right, let's keep moving on. Now that you've seen a single selection, I want to talk about all the possible types of row and column selections. So what I'm specifically talking about is what are the possibilities that rows and calls can be. So here they are both lists. Now there are other combinations that it can be, but that was just one combination, is that each one can be a list. So that's right here. But they can also be a single label, such as a single string. So if you're selecting just one row, you can just put that string, or one column, you can use that string. We just saw the list of labels. You can also use a slice of labels. We'll see that in another video. Or you can use a Boolean series. This will be covered in a later chapter. Okay, so let's go ahead and make another selection. Here we're going to select 2 rows and a single column. So I'm going to take df, and you know what, we'll actually define the rows here. Let's pick 2 rows. Let's do Jane and Dean. And for the columns, we'll select a single column here. And we won't use a list for this. We'll use a single label. That's what I mean right here, is a single label. Here it is a string. So we'll just use loc again because we're selecting by label. Put the square brackets there. Put in the row selection and the column selection like this. And then make our selection. So here, notice it has correctly selected 2 rows with a single column, the height column. And notice that this has returned a series. It has not returned a data frame because we have a single dimension of data selected for the columns. So that is important to know. If you put square brackets around here, it will select it as a 1 column data frame. So that is a difference. Now you don't have to create separate variables each time. I do this just for clarity when teaching. When you feel a little bit more comfortable, you can just place them all in the same indexer here. So instead of just writing out rows in a separate variable, we can say Jane and Dean. That's going to be the row selection. So that goes in the first slot. We do comma, and then we'll do height like this. As you can see, it might be a little bit confusing when you first see this, but this really is just in that rows position. Rows always comes first, and then calls comes second. Here is just a string like that. So that'll make the exact same selection. So that gets us started selecting with the loc indexer. In this video, we're going to cover how we can use loc with slice notation. So we just saw how we can use a list with loc and a single label with loc. Now we're going to see how to use it with slice notation. So a quick review of slice notation. There are 3 components: start, stop, and step. Each one is separated by a colon. Also, each one is optional, and we'll see the different combinations below. So one thing to know about slice notation with loc is that it is inclusive of the stop label. This is not how slice notation works with lists. This is different. So you'll see that it does include the stop label, and you can slice both rows and columns. So here's some example slices, and we'll do a few of these. So you can slice, and you can provide the label, and you must provide the label since loc is label based. So here, this slices from the label Nico up to and including Christina, and with a step size of 2. So this one actually has all 3 components: start, stop, and step. Now, like I said, all 3 are optional. The next one goes from Nico through Christina, has no step size. If there is no step size, then the step size is 1. Step size always has to be an integer. This one is Nico, begins at Nico, there's no stop, and then has a step size of 2. This means it goes from Nico all the way to the end, stepping by 2. This one has no step size. It's just Nico as the start. That's all you get. So it goes from Nico all the way to the end, stepping by 1. This one has no start, which means the beginning is actually at the very first. So it starts from the beginning, goes up to Christina and steps by 2. You can have an empty slice. So this is actually a legal command, and this will just return all of the rows or the columns. So it goes from the start to the beginning with a step size of 1. All right, so let's go ahead and look at our data once again. And let's do some slice notation with loc. So let's slice from Nico. Let's go ahead and do this to Christina. So that'll be the row selection, and then the column selection. We can also use slice notation here. We can go from color to height and just grab every single one. So there we go. We go from Nico to Christina. Notice that it is inclusive of the last one. And here we go from color to height. So we can do different arrangements of this one. Let's see a few more. Now, instead of slice notation for one of the selectors, we can use something else. So we can say, all right, we just want color and score, and we can pass that in as a list. So we have slice notation for the rows and a list for the columns, and that works as well. We can just stay here. We can add the step size. We can change the step size to 2. So it goes from Nico to Christina, stepping by 2. We can get rid of the end. We can say go from Nico all the way to the end, step by 2. That doesn't change it because Christina is close to the end and there's no other one after that. But we can say step by 3. That will certainly change things. We can have a slice where we go from the beginning to the end, stepping by 3. So there's no start, there's no stop, which means that it goes from the beginning to the end, like that. We can go from the beginning to a particular label, so from the beginning to Dean, like that. And again, all of these slices work with columns as well. I've just showed you most of the time with rows. Okay, so we just did that. We sliced both the rows and the columns. Now let's see an example where we select all of the rows and just some of the columns. So you can do this. You can say, all right, I'll have an empty slice, which just means go from the beginning to the end, stepping by 1. That's just grab all of them. And then we can slice some of the columns. So we can start from the beginning and go to, let's just say, age, like that. So that is possible. And so that, yeah, that certainly works. Now we can keep on moving. Let's see another example. We can use a single column or a single colon to select all of the columns. So this is how you select all of the rows with slice notation. So you just want to slice the columns but not the rows. Now we can do the same thing with the columns. Let's go from Nico to Dean, like this, and then slice all of the columns like this. So the row selection is that slice. The column selection is just the empty slice. So that'll get us all of them. Now, Pandas allows for a shortcut. You don't have to provide the column selection in with loc. So sometimes you'll see this, and that'll do the exact same thing. It'll just always select all of the columns. You do always have to provide the row selection, so that comes first, so there's no going around that. You have to provide the row selection. So there's no shortcut here. We just have to do that. But for the column selection, if you're selecting all of the columns but only a subset of the rows, then you don't have to provide the columns because it comes last. Now, I kind of like using this notation when starting out, even though it is unnecessary, because it just reinforces the fact that loc simultaneously selects rows and columns. So here's the row selection, here's the column selection. All right, so we've already changed the step size. We already saw how to do that. And that pretty much wraps up all of the examples that I have using slice notation. In this video, we'll look at other subset selections with loc. So you can select a single value in your data frame if you provided 2 specific labels. let's go ahead and get started. Here's our data frame. This is one selection we haven't done before. So let's just say we want to select the row Aaron with the age. So this will return, this is only one value, right? Aaron and age. This will return a scalar value. It does not return a data frame, nor does it return a series. It returns that single integer. So when you return a single value, we use the word scalar to represent that. So this is a scalar value that it has returned. Okay, so let's select a single row as a series with loc. So df.loc over here. So we're going to use a label, not a list. And let's go ahead and select that row Aaron. And we could use an empty slice. It's not necessary here for the column. So we're going to select just the row Aaron with all of the columns. Let's go ahead and see what this returns. It's a little confusing. So it's selected this row. So you can see here state is FL, color is red, food is mango, and so forth. So the data lines up, but the orientation has changed and it has returned a series. So I believe this is somewhat confusing. You might expect to see a single row data frame like this, but it returns a series which is displayed vertically in the notebook. So selecting a single row is a little confusing output. What you could do is you could just take this, and if you want to maintain the orientation, you can just turn your selection into a list instead of a single label. So now Aaron is in a one item list, and now it'll just the same orientation as the data frame. So this is a one row data frame with these 6 columns. Okay, so that's it for the other examples, and that concludes basically virtually everything there is to know about loc, except for the Boolean indexing, which we'll talk about in a later chapter. So a little summary here. So loc is primarily label based, except for those Boolean indexing. It is able to select rows and columns simultaneously with this syntax, df.loc, and then rows, calls. And then what can rows and calls be? They can either be a single label, like one string, a list of labels, a slice of labels, or a Boolean series. So they can take all of these. Remember, loc has different rules than just the brackets appended directly to the data frame. And then there's a comma separating the row and column selection. In this video, I'm going to complete the exercises at the end of notebook number 2. So the first thing we'll do here is read in the movie data set and note that the title has been placed in the index. Okay, so exercise 1. Select columns actor 1, 2, and 3 for the movies Home Alone and Top Gun. We need to use the loc index. What we can do here is just use a list for the rows and for the columns actually. So calls will be actor 1, 2, and 3 like that. And then we just take movie and use loc, pass in rows, calls, and we should get exactly what we want. So it'll be a much smaller data frame than our original, just selecting 2 rows and 3 columns. All right, exercise 2, select columns actor 1, 2, and 3 for all of the movies beginning at Home Alone and ending at Top Gun. So it's going to look pretty similar. I'm just going to copy and paste this. The columns are the same. The rows need to be a slice from Home Alone to Top Gun. Now, one thing you cannot do in Python, this is illegal. This is incorrect syntax. You cannot assign a slice like this using slice notation. Slice notation is only viable inside of these square brackets. So what we'll do here is actually the wrong one. So we replaced our rows with slice notation, and there we go. So that's the answer I'm looking for. All right, so number 3, select just the director name column for the movies Home Alone and Top Gun. All right, so just the director name. So let's just go ahead and write this out without assigning any variables, Home Alone and Top Gun. And we just want the director name, so we'll just go straight to a label. We don't need a list over here. And it's not DF, it is movie. All right, so there we go. We get returned a series. All right, it says repeat exercise 3, but return a data frame. All right, so to return a data frame, we need to place the label and into a list. So we create a one item list, and that'll make it a data frame. Exercise 5, select all columns for the movie The Dark Knight Rises. So here we're just going to select all the columns. We're selecting a single movie like this, and it's unnecessary to put the colon, but that's how you can select it. So there we go, The Dark Knight Rises, like that. Again, we don't need the colon. I like to use it just because it reinforces the fact that Loc selects simultaneously rows and columns. Okay, so we're selecting this particular row, The Dark Knight Rises. All right, repeat exercise 6 or 5, but return a data frame. All right, so we'll do the same trick. We'll put this into a list like this, and that'll return as a data frame, makes it much easier to read, and keeps it in the same orientation. Exercise 7, select all columns for the movies Tangled and Avatar. Okay, so we want movie.loc and say Tangled and Avatar like that. Those are the row selection. And the column selection just says select all of them. Again, we don't need to put the colon, but there we go. We use a list for our selection in the rows and just an empty slice for the columns. What year was Tangled and Avatar made, and what was their IMDb score? Well, we can just look over here, but we can also just select those particular columns, so we can get the year column right there and their IMDb score, which is over here in this last column, like that. So we need just the information that we need by selecting it like this. All right, so what is the data type of the year column? All right, well, we're going to use the dtypes attribute, and we see that it is a float. So there we go. Exercise 10, use a single method to output the data type and number of non-missing values of year. So we learned about this previously. There's an info method, and here's the year. We can see that there are 48 and 10 non-missing values. And since there are 4,916 values, we know that there are some that are in fact missing. All right, exercise 11. Select every 300th movie between Tangled and Forrest Gump. So why doesn't Forrest Gump appear in the results? Okay, so we do movie.loc, and we'll say Tangled all the way to Forrest Gump, like this. And this is not every 300th just yet, but I just want to show that here is Forrest Gump in the result. It is inclusive, but now to do every 300th movie, and just to say we select all of the columns like that, we can put a comma and then a colon. When we do this, we see that Forrest Gump doesn't appear in the result, even though I said that slice notation is inclusive of the last one. Well, here it's just not a multiple of 300, and that's the reason. So it's not going to be inclusive if it's not an even multiple of that. All right, so that does it for the exercises. Welcome to notebook number 3, selecting subsets of data from data frames with iloc. So the iloc indexer selects subsets of data only by integer location. It's very similar to loc, but uses integers instead of labels. So if you understood loc, then you should understand iloc. All right, so it's able to do the same thing, simultaneous row and column subset selection, and the syntax will look like this, df.iloc, then you have your row selection and your column selection. Okay, so let's go ahead and get started here. Let's read in that same sample data frame, putting the name column into the index. So what exactly is integer location? So each row and each column, in addition to the label that you see, can also be referenced via integer location. So the integer location is pretty simple. It just starts at 0 as the first one and then goes down. So 0, 1, 2, 3. So Penelope here can be referenced by integer location 3. State over here can be referenced by integer location 0. So just like with LOC, there are possible types of selections for iLoc. Like what could the rows and columns be? Well, they can be a single integer, a list of integers, or a slice of integers. iLoc doesn't actually accept a Boolean series like LOC does, so that's one small difference. Let's go ahead and see some of these examples. So we'll select some subset of rows and columns. So let's say the rows we'll select integer location 2 and 4 and 0. They don't have to be in order. And for the columns, we'll select, let's say, just 5 and 1 like this. And then all we have to do is do df.iloc, use the square brackets, pass in our row selection and our column selection, and then get the result. So we got integer location 2, 4, and 0. That's 2 over here. 4 is Dean, Jane is 0. And then score and color, that's 5 is actually the last one, and color over here like this. Okay, great. So both of these are rows. With iLoc, you can actually use negative numbers. So let's say we want to do -2. So this is the second column from the end. So height, and say +2. So this will be food like that. We could get the last row over here, which should be Cornelia. So this is just another combination. We're using two lists, and also it accepts negative integers. So let's take a look at one with slice notation. So instead of calls, and I'll just comment that out for a second, we'll say I want to slice from the second integer location up to the 5th. And now when you do slice notation with iLoc, it is exclusive of the last one. So this functions similarly as the slice location for your standard lists in Python. So it excludes the last one. It gets integer locations 2, 3, and 4, but it excludes 5. So with LOC, it does include the last one. So that is a small difference. They both can be labels here. So we can go from the beginning up to label 3 like that. So get the first 3 rows and then these columns. You can of course add a step size. So here we can do a step size like that. That's great. Let's select a single value. So just like with LOC, if you just use 2 integers, say 2 and -1, it'll get, okay, so this is Aaron is the second, -1 is score, so it should return 9. And that's what it does. It returns that scalar value. And let's look at, let's say we select the second or integer location 2, but use a list over here. So we'll just say 0 and 4. And so this selects for Aaron, state and height like that. And it returns a series because we're only selecting a single row over here. Again, that's a little confusing. It might be easier to convert this to a list and return a data frame so that you can keep the same orientation. All right, so I think that covers most of the combinations with iLoc. Rows and calls can be any of these 3, and they're all valid. Okay, so a quick summary with iLoc. It's analogous to LOC, but it only uses integer location. One thing to note is that in the Pandas documentation, it does use the word position. So you'll see that I like to use the term integer location. It's just more verbose and just more specific. Here is the generic syntax. It selects rows and columns simultaneously, rows, comma, calls. And we talked about this. These are the 3 possibilities that you can pass to rows or calls. They can either be a single integer, a list of integers, or a slice of integers, and then make sure you add a comma between the row and column selection. In this video, I'm going to do the exercises at the bottom of Notebook 3. So these are going to use iLoc, integer location. I'm going to read in the movie data set again. And just note that title is in the index. So exercise 1, select the columns with integer location 10, 5, and 1. So I'm going to do iloc. So just the columns, which means that we're going to select all of the rows. And then we just use a list over here, 10, 5, and 1, like that. So we can use slice notation here for all the rows. And that's how we get just those 3 columns. All right, exercise 2. Select the rows with integer location 10, 5, and 1. Again, we're going to use iloc here. Now we're going to use a list for the rows like that. It's unnecessary to put the colon for the columns, but we can go ahead and do it. So we just selected those 3 movies. All right, so exercise 3. Select the rows with integer location 100 to 104 along with column integer location 5. So this implies a slice. So we go from 100, we're going to have to say to 105 so that it captures 104. And then along with the column integer location 5, so like that. So that will do it. That's 100 to 1, 2, 3, 4, and this is integer location 5. Exercise 4, select the value at integer location 100 and column integer location 4. So this is a single scalar value that we are selecting. So 100, 4. Exercise 5, return the result of exercise 4 as a data frame. All right, so we've returned a scalar value. To make it a data frame, if you just make one of them a list, this will return a 1 value series. You have to actually make both of them a list. So this will make a 1 by 1 data frame. This is kind of helps you out to see, all right, well, what was the title and then what was this the column name. Exercise 6, select the last 5 rows of the last 5 columns. Okay, so the last 5, we could think about using negative numbers here. So we'll slice from -5 to the end. That'll be the row selection. And the same thing for the column selection, -5 to the end. All right, exercise 7. Select every 25th row beginning, or select every 25th row between rows with integer location 100 and 200, along with every 5th column. Okay, so this will mean that we're going to use a step size. Every 25th row between 100 and 200, so that'll be that. Along with every 5th column, so that means no beginning, no start, no stop, but every 5th, so step size of 5. Exercise 8, select the column with integer location 7 as a series. Okay, so we're going to select all of the rows, but just integer location 7, and by default that will return a series. So there we go. And then exercise 9, select the rows with integer location 999, 99, and 9, and the columns with integer location 9 and 19. So this will just be a couple of lists. All right, so iloc here, so we want 999, 99, and 9, along with 9 and 19 for the columns. Okay, so it's going to select this small little data frame. All right, so that does it for the exercises. Welcome to notebook number 4, selecting subsets of data from a series. So far we've only selected data from a data frame. Now we're going to select data from a series, which is actually a little bit simpler because series have no columns. So the series have the same 3 indexers available, each with their own rules. So you have just the brackets, loc, and iloc, and we'll cover all of them. Let's go ahead and get started over here. And this time we'll read in this movie data frame. And what we need to do first is select a series so that we can actually start selecting from it. And what we'll do is select this last column, IMDb score, and we'll assign it to this variable IMDb. So here are the first 3 values. Now, just the brackets. Now remember, with a data frame, just the brackets, I showed you how to select a single column like this, or multiple columns using a list. So series don't have columns, but interestingly enough, just the brackets does work and does select. So let's say so here are the values over here. I can put in a label like Spectre and it will return a value. That's great. But it also works with an integer, and this will give me the whatever movie is at that location. So while you might think this is advantageous, I find it to be a little hazardous because you don't know right off the bat if you're selecting by label or integer location. The rules are a little bit ambiguous. So I like to be explicit and only use loc and iloc when selecting data from a series. So I don't really use just the brackets like this. Okay, so let's move down, and now we're going to go through examples of loc and iloc. And just going back up for a second, one of the other reasons is that you can have integers as the index value. So you're not always going to have strings, so it's not always apparent that 100 will select by integer location, or will it select the label 100, which could be at some other location other than the 100th integer location. So you're not, so the rules over here, it's just a little ambiguous, and that's why I like to be certain and use loc and iloc. So when I use loc, I'm certain I'm selecting by label. When I use iloc, then I'm certain I'm selecting with integer location. So this is explicit. This is just, ambiguous. So that's why I choose these over here. All right, so let's go ahead and see some examples. So IMDb, and we're going to start off with loc over here. So this is by label, so I know that if I type in a movie, such as Home Alone, it will get it like that. If I try to use integer location here, it's going to say, oh, I don't see this label. This is a key error, and so that won't work. All right, so you can also use a list of labels. So that was a single label, a list of labels. So we'll just do Home Alone and Tangled. So it'll return a series here if you use a list. A single one returned a scalar value, so that's important to know. And then of course you can slice. So we can go from Home Alone to Tangled, and it must be the other way around. So Tangled might come before Home Alone. So we can go ahead and change their order. That's why there was nothing there. And there we go. So Tangled did come first, and then Home Alone over here. So remember, with loc, it is inclusive of the last one. We can of course add a step size like that. So every 20th movie from Tangled through Home Alone. And then we'll cover a Boolean series label. So that's a single label, a list of labels, a slice of labels, and a Boolean series is what you can pass over here into loc. All right, so let's go to iloc, and it works just like with data frames. You have to give it some sort of integer location. So here we go again, IMDb. Let's look at some examples. So a single integer, say the 9 at position 900 has that score. You can use negative numbers, so the very last movie has this score. You can use a list of locations. They don't have to be in the right order. There we go. I did 100, so it actually selected this one twice. So that's actually possible. So this was a mistake. I meant to do 1,000, but yes, you can select the same item twice, and that's what I did. I meant to do this. And then of course you can do slices. So we can do 50 to 100 by 5 or something like that and get this. All right, so that's how you select subsets with a series using iloc. Okay, so here's the full summary for series selection. You do have the three indexers available, just like you do with a data frame. I just suggest not using the brackets. So the loc indexer selects by a single label, a list of labels, a slice of labels, or a Boolean series. The iloc, that's what should say iloc, selects by a single integer location, a list of integers, or a slice of integers. And there are no columns, so selection is only based on the index. Yeah, so we don't have to worry about like rows, columns here. It is just, index based. In this video, I'll do the exercises at the bottom of notebook 4. So we're going to use this duration column to start off with. This is from that movie data set. So it says, how long was the movie Titanic? So I'm going to use the loc indexer over here because I'm using a label, Titanic. So that'll give us the value, 194 minutes. How long was the movie at the 999th integer location? Well, that'll use iloc, and not movie, but duration, excuse me. Exercise 3, select the duration for the movies Hulk, Toy Story, and Cars. So I'll go ahead and just copy that duration.loc. I need a inner list here and just use those 3 movies. So this should return a series in that order. Exercise 4, select the duration for every 100th movie from Hulk to Cars. So duration dot, again we're going to use loc, and slice notation from Hulk to Cars going by 100. That's how we'll do that. Exercise 5, select the duration for every 10th movie beginning from the 100th to the end. So this will do iloc. So beginning from the 100th, I guess technically this should be 99, but really the point is just to use slice notation and know that to go to the end we don't use stop and use 10 like that. Alright, so that'll do that one. Alright, so we're going to read in the bikes data set and then use the wind column for all of these next exercises. So we've read in the bikes data set, we selected this wind speed column, saved it to the variable named wind, and then did that. So what type of index does the wind series have? Well, we didn't put any special column into the index, so it actually uses the range index. So we look at it like this. So again, this is the default simple index. It's just integers beginning at 0. So we'll just say a range index. From the wind series, select the integer locations 4 through, but not including 10. So we do wind dot iloc, so from 4 to 10, and that should do it. So in this case, this is important. The labels are the same as the integer location. So this is label 6. It is also integer location 6. Exercise 8, copy and paste your answer from exercise 7, but use loc instead. Do you get the same result? Well, no, you're not going to get the same result. We're going to get one more value over here. It is label number 10. So remember, loc is inclusive of the end, and we can use integers here because the labels are integers. So we go from 4 to 10, and it's inclusive of 10. Here, iloc is exclusive of the last one. So that should help you see the difference between loc and iloc. All right, so that's it for all of the exercises. Welcome to notebook number 5, Boolean selection, single conditions. So we're going to embark on a new topic here called Boolean selection, also known as Boolean indexing, which is the process of selecting subsets of rows from data frames based on the actual values and not by labels or integer locations. So up to now, our subset selection has been done by either row or column labels or by integer locations. So we haven't looked at the data at all to select our subsets. We've only looked at the index, the labels for it, or the integer location, and the columns, the labels or the integer location. In this notebook and in the following couple chapters, we're going to look at the actual data to determine which rows we want to keep. So here are some examples of Boolean selection in plain English. So we can think of using like the bikes data frame. So here we say we want to find all rides by males. Another selection could be that we want to find all rides with a duration longer than 2 hours. Find all rides that took place between March and June of 2015. Find all rides with a duration longer than 2 hours by females with temperature higher than 90 degrees. So all of these queries, which is another word for these sentences right here, are looking at the data and testing out specific conditions. So if the condition is met by that row, then we keep that row in our data set. If not, then we discard it. So here are just some of the fundamentals of what Boolean selection is. So all queries have a logical condition. So there's always a true or false outcome for each of these conditions. We're going to look through each row one at a time and determine if it meets the condition, and if it does, then it is kept, and if not, it is discarded. So that's what this second statement here says. every row is either kept or discarded. And then what that means is that every row has a true or false value associated with it. So does it meet the condition or not? And that's where the term Boolean comes from. Okay, so let's go ahead and look at some sample data here. And so we can manually go through here and look at just a small data set, and one that we can just look at the entire data set and determine the Boolean condition of each row. So we're not going to do this. We're only going to do manually here just for this example, and then we'll see how it is automated later on in a future video. Okay, so let's just say we want to look at this data set, and each row represents a person, and we want to filter for all those people who are younger than 30 years of age. So we want to keep everybody who is less than 30 years of age. So what we do here, if we were doing this manually, is we look at the age column, and then we one by one can label each row as either true or false. This list of Booleans corresponds to the age. So 30 is not less than 30, so that's false. 2, 12, and 4 are, so these are true, and then the last 3 are false. Okay, so what we can do here is we can create this list of Booleans that align with the rows that we want to select, like that. All right, so and the way to actually do the selection, so once you have this, is to pass this list into the square brackets that are attached right to the data frame, and we get our selection. So we filtered for only those people that have an age less than 30. So just these 3 rows right here. Okay, so you should be wondering right now, why is this working? I mentioned that the columns are for selecting, or this brackets are for selecting columns. Now, there's an alternate use case here. There's more rules actually for just the brackets. And if you pass in a list or a series that is the same length as the data frame, and it is of Booleans, then it will do Boolean selection. So this is called operator overloading. So this square brackets is overloaded, which means that there's different rules based on what is passed to it. If you give it a single string, right, it'll return that column as a series. If you get a list of strings, it'll select those columns as a data frame. Now, if you give it a sequence of Booleans, then it selects by rows. So it goes from selecting by columns to going by rows depending on what is passed to it. So this is actually something that makes pandas quite confusing, is this operator overloading, especially with just these brackets. It switches from selecting columns to selecting rows. So again, if you do pass in a sequence of Booleans, first of all, it has to be the same number as the number of rows, and then it'll just return the rows that are true. Now, as usual, this does not change the original data frame. It creates a copy of this new data set, and you'll have to assign it to a variable if you want to keep it. All right, so in the next video, we'll see how we actually do Boolean selection without manually typing in the true and false values like this. In this video, we'll be doing practical Boolean selection. So you'll never be writing out the Booleans like we did in the last video. Instead, you'll be creating Boolean series from a column of data using one of these comparison operators. So we'll show a couple examples here. Let's go ahead and read in the bikes data frame so we can see that. And let's come up with a simple query. Let's say we want to find the number of trips, bike rides, that have a trip duration greater than 1,000. So the way this is going to work is that you'll select the column you want to test on. So say this trip duration column, and let's just select it as a series, and then you'll use one of these 6 comparison operators. So here we want to test that this trip duration column, which happens to be in seconds. So this is going to test whether a bike ride was longer than 1,000 seconds like this. We'll compare it to the number 1,000. So what this does when you write this command is it compares every single value in the series, so all 50,000, to this number 1,000, and then it'll return a Boolean series that is the same length, but has turned into just a series of Booleans. So you can see the data type right there is bool. So what I like to do here is to assign this result. So you'll need to assign this result, this Boolean series, to a variable name. I like to choose filt because we are filtering out the data to just the values that meet the condition, which are true. So you can see here 1040 is the only one in the top three that is greater than 1000. So that's the first one. We can do filt.head like that. So filt is now our Boolean series. And then, so that is step one for Boolean selection. Step two is simply to pass in this filter into just the brackets like that. And then it filters for only the true values. So only the rows that evaluated as true here will be shown in the result. And you can see, and you can what you should do is verify that all of these are greater than 1000. So we can make a new variable and say bikes TD for trip duration greater than 1000 like that. And now we've saved our result to another data frame that has just those trips greater than 1000. So one little question here, how many rows have a trip duration greater than 1000? Well, we could just take the length of this. We know that, we see here, all right, 10,178 meet that condition. Now, you don't have to do Boolean selection in two lines like this. And really the full Boolean selection, what I like to do, you don't have to print out the filter once you get a little bit more comfortable, is simply to do this right here. Just do the filter, pass it in one line, and then put the head like this. So that's how I would typically write it. Although you can do this in a single line. Let's go ahead and copy and paste this again. And the reason I want to show in a single line is that a lot of people will write this in a single line. You can simply put the filter inside of these square brackets, and it looks a little funny, which is why I like to separate it out at first. You have bikes next to each other twice, but it is this piece that is run first. So the Boolean series gets created, and then it gets passed into these square brackets selection operator like that. And finally, the Boolean selection is made, and then we do dot head. All right, so let's look at another condition. So we'll look at an equality condition. And let's look at the events column. And here we have a bunch of events. And we can say, let's just filter for the ones that are partly cloudy. So here we have a bunch of strings. So we're going to use equality operator. So it's two equal signs, just like in normal Python. We'll test it equal to partly cloudy. So we'll just do this in one line. Bikes, we'll use this filt variable again. And then we'll pass in filt into the square brackets. And we will get, should be just the events that are partly cloudy. And it looks like it has done exactly that. All right, so here is a summary of the single condition Boolean selection. So again, we're just doing one condition here, looking at testing one thing per row. In the upcoming chapters, we'll test multiple things per rows. All right, so the first step, number one, is to create a Boolean series, commonly done by comparing one column of data to another value. That's what we've done. And then we just place that resulting filter, which is going to be a Boolean series, inside of these square brackets to filter the data. All right, so that does it for Boolean selection single condition. All right, let's complete the exercises at the bottom of Boolean selection single conditions. Exercise 1, find all the rides with temperature below 0. So we have this temperature column, and we're just going to test that it's below 0. And then we can assign that to filt, and then we can do it like this. Let's use dot head so we don't get too much output. So here's the temperature when it's below 0 Fahrenheit. All right, ride number 2, or exercise 2, find all the rides with wind speed greater than 30. So that should be just about the same thing. So we're going to test that it is greater than 30. Like that, we create the filt. We pass into the bikes data set, and let's just see if there are any with that wind speed. That's pretty high wind speed. You can see that there aren't too many. by just looking at the index. This aligns with the integer location. So the first ride wasn't until the 2000th ride. All right, so exercise 3, find all the rides that began from Millennium Park. Let's go ahead and just copy that. And this will be an equality condition. So bikes, and this is from station name. And we're going to set it, we're going to test equality to Millennium Park, and then we'll do dot our filt and see if that is there. Now, notice, I'm going to just do one quick thing. If we misspell this, say do Millennium Parks, we'll get an empty data frame. So this is still a data frame. It just has no rows. It has all columns, but no rows. So it is possible to get a zero row data frame. Find all rides with wind speed less than 0. How is this possible, right? Wind speed should always be positive. We can just copy and paste our work from over here, and we'll say less than 0, so that should be a problem. Okay, there are some wind speeds less than 0, and so that's obviously incorrect, and they might have just used this number to represent a missing value. So you'll have to read the documentation on this data set more precisely to figure out what does this number mean. Maybe it's just unable to be recorded. Our exercise 5, find all the rides where the starting number of bikes at the station start capacity was more than 50. So start capacity and end capacity. So let's do that. Filt equals bikes of the start capacity to be greater than 50, and then we'll just pass that in over there. And as you can see, I wrote the name down. So start capacity. Okay, so I have an extra T, and there we go. All right, exercise 6, did any rides happen in temperature over 100 degrees? So we'll test that. Temperature greater than 100, and we'll pass in filt like that. Oh, not 1,000, that would be deadly. No, actually, so there were no bike rides over 100 degrees. All right, let's read in a new data set here, the movie data set. Put the title into the index, and we'll complete the next few exercises. Number 7, select all movies that have Tom Hanks as actor 1. So we're gonna make sure we do movie, actor 1, and Tom Hanks like that. And then we'll pass in filt like that. So let's see. Oh, so, okay, these are all of his movies. All right, so we just used the equality condition, and he's done quite a few movies. Exercise 8, select movies with IMDb score greater than 9. All right, so we have movie, and then you have to know the column name exactly, and it's over here at the end, and let's just copy it like that. So we're going to test that it is greater than 9, and then again we just pass it into the brackets. Hopefully we're getting very good at this with all this repetition. Write a function that accepts a single parameter to find the number of movies for a given content rating. Use a function to find the number of movies for these different ratings. Okay, so we have to define a function here. So we'll just call it find, and it'll pass in a data frame, and it will determine the number of movies. So we're looking for the number. So let's make our selection. So we'll say df of the content rating, and if we look like this, that is this column. So we want that. We want to test that content rating, and it says single parameter, but I guess we'll just assume movies in our data is in our namespace, and we'll test equality against that rating. So we'll get the content rating column, and we'll test it against the passed in rating, and then what we'll return is the length of the filtered data frame. I should call that movie. All right, so we'll do the filter right here, and then we'll take the length of it, which returns the number of rows. So now we can do find of, say, R. That should give us the number of R-rated movies. PG-13, there's none of those, but there are 1,411 of that. And then lastly, we will find the number of PG movies, 686. All right, that does it for the exercises. Welcome to notebook number 6, Boolean selection, multiple conditions. So in the last notebook, we covered single conditions. In this notebook, we're going to do multiple conditions. And in regular Python, when we talk about doing multiple condition logical operations, we use these logical operators and, or, and not. So I'm going to start here using some basic conditions. So we'll begin with just a single condition over here. So is 5 greater than 2? And then we can have an and to do multiple conditions. So this is where both conditions must be true. So 10 greater than 8, well, they're both true. So this whole expression evaluates as true. If one of them is false, then the expression evaluates as false. Then we can do an or condition when you have two separate conditions over here, and only one of them must be true for the whole thing to evaluate as true. We have that. The not operator will take an entire expression. You have to be careful here, and it will happen first. It'll actually execute before the or condition. So if we want to say not of this entire condition, we have to actually add parentheses over here. So this will invert that to false. Now, in pandas, you cannot use and, or, and not. These are only for like scalar conditions like this. They do not work for comparing when you're doing multiple Boolean conditions in a series. We have to use these different operators over here, the ampersand for and, the pipe symbol for or, and this tilde for not. So we have different syntax to represent the different logical operators and, or, and not. All right, so let's go ahead and get started over here. So we're going to read in again our bikes data frame, and let's do our first multiple condition, and let's find rides longer than 100 seconds by males. So the way I like to introduce this is to create two filters, one for each condition. So we have filt 1, say bikes, the trip duration, we want it to be longer than 1,000 seconds. Okay, that's the first one. And we have filt 2, we have bikes of gender equal to male. So I've already seen how each one of those acts independently. Now, what we want to happen for this, to make this correct selection, is that both of these have to be true. If we want rides longer than 1,000 seconds by males, then this is an and condition. And then our final filt, so this is the one we will actually pass into the square brackets, is just going to be a combination of filt 1 and filt 2 like this, with an ampersand separating them. So it'll apply element by element conditions, or this element by element and operation. And let's go ahead and execute this, and then we'll see filt dot head is now a single Boolean condition. Let's go ahead and look at each one separately real quick. So we have filt 1 dot head, and excuse me, we have filt 2 dot head over here. So filt 1 is only true for this for the third row right here. Filt 2, which is just that gender equals male, is true for all of them, and maybe we should look at the first 10 to see if we can have a female in here. So the last one is female. Let's change it to that. So in order for the overall filter, this one to be true, they both have to be true, and that's true for index 2 and index 8. So that's true for both of those like that. You can see there. And now let's look at, we already have it over here. Let's look at filt number 10. So this is the only, so number 2 and number 8. Again, those are the only ones that will be true overall, that meet both conditions. Okay, so the last step here, and now I will just delete these, is to pass in this final filter into bikes. And we'll just do dot head. So in this case, you have to be male with a trip duration greater than 1,000. So both of these have to be true in order for the entire expression to be true. All right, now I'm going to rewrite this in a single line. Sometimes you will see this, and let's go ahead and just copy this over here. So what's common is not to write this in separate filters. The reason I do this in the beginning is just so it's more instructive to see what's happening, but you certainly can write this in one line like this. Now, if we try to do this, this looks like it should work, but in fact you'll get an error here, and this is because this ampersand actually has higher precedence than this greater than sign. So what's going to happen first is Python will try to evaluate this 1,000 and bike's gender, and that doesn't really make any sense, so you're going to get an error here. What you have to do is wrap parentheses around each condition. So each condition must have parentheses around it like this, or else you will get an error. So this forces Python to do this first, then this condition, and then apply the AND operation. And I will go ahead and just do the filter like this. So we'll pass it immediately into here like that. So that'll give you the exact same result. You can go even one step further and copy and paste that all into here. That is a lot on one line. I kind of like to separate things out. So there's nothing wrong with writing the expression like this. I think it's pretty clear to me, especially when you're first learning to write your conditions separately like that. Now let's move on to an OR condition. So we could say, let's go ahead and actually just copy and paste this and move it down here. So let's say we want a trip duration, let's just say greater than 5,000, or the gender equal to female, and we'll change this to the pipe symbol, which does the OR operation. So either trip duration is greater than 5,000 or the gender is female. And let's go ahead and just pass in the filter directly to our data frame. And so here we go. So we can see it's always good to double check to see that the filter worked properly. So here we have gender female. It's only one of them has to be true. Now if the trip duration is 5,000, or if the gender is male, then the trip duration better be greater than 5,000 to make the other one true as well. Okay, so that is just the very basics of doing multiple conditions with AND and OR operations. Let's continue by inverting a condition with the NOT operator. So we'll begin with a simple condition. Let's say trip duration. You want to filter for those trip durations greater than 1,000. Well, the NOT operator, which is done by this tilde character, will invert things, but you have to wrap the condition in parentheses because this tilde has higher precedence than the greater than sign. So this will just invert all these falses to true and true to false. And so it will become this. Let's go ahead and make the assign to the filter and then actually do the filtering like this. And this should only return trip durations that are less than or equal to 1,000, and that's what it does. So in actuality, you would never write this type of thing in pandas because there's just a much easier expression, and that is to use the less than or equal to. That is the natural inversion. You would not use a NOT operator in this instance. It's just to show you how to use it with a single condition. Now let's look at a more complex example, which I already have written out. So here we have, we're filtering for trip durations greater than 1,000 and the gender equal to female. And at first we do this OR condition, and let's go ahead and run this just as a OR condition without the NOT operator first. So either one of these has to be true. And let's go ahead and look at a few more. So either the gender is female or the trip duration is greater than 1,000. Now, the inversion logic over here, so let's say we want to invert this. So we would take the whole operation and then wrap parentheses around it, and then use this tilde over here like this. And so this would actually, with the logic, have to have trip durations less than equal to 1,000 and the gender equal to male. So let's go ahead and do this. So these are the ones that do not, or that now fit this these both conditions. So they have to be male and trip duration less than or equal to 1,000. Okay, again, you would probably not use a NOT operator here. You would try to write things using the positive without trying to use the NOT operator. The reason is because it just adds a little bit more logic to what's happening. So I tend to try to figure out a way to write my conditions without using the NOT operator, but sometimes it's necessary and it does make sense. Let's look at one more example over here. So let's say we have two pretty large conditions. So the first one, let's see if we can understand this. It says we want the gender to be male. We want trip duration to be greater than or equal to 5,000 and less than or equal to 5,000. So we're looking for rides by males with a trip duration between 5 and 10,000. And then the second filter says we want rides by females with trip duration between 2,000 and 3,000. Notice these are both and conditions. These are two separate complex conditions. And then at the end, we will use this OR filter or this OR operator to say either one. So you have to be one of these two categories, male and trip duration between 5 and 10,000, or female and trip duration between 2 and 3,000. That's what this final thing does. And let's look at a few more just so we can verify here. So a male between 5 and 10,000, check. Female between 2 and 3,000, also good. Now again, you can actually add the not at the very end. If you want to invert this, this will get everybody else. So these are pretty narrow conditions. So this should pick up most everything else. And if you notice over here, before I run this, you can see how there's a big gap between rows, which means very few rows actually satisfy this condition. So when we invert this, this will grab everything else, which is most of the other ones. And you can see here it actually grabs the very first 10. So only a few rows meet this very specific condition, and the not operator verifies that. So there's all sorts of different complex conditions you can do with and, or, and not, and these are just a few more examples. Let's cover how to do many equality conditions in a single column. So this is most common with string columns. Let's go ahead and take a look at the bikes data frame over here and into this events column. So let's say I want to filter for specific weather events. And let's say I only want to see the rain, snow, thunderstorms, and sleet rides. So one way to do this is with multiple OR conditions. And this makes a very long condition. So we test here for rain, or that bikes events equals snow, or it equals thunderstorms, or it equals sleet. So keep in mind that every condition is wrapped in parentheses like that. The whole thing is wrapped in one large parentheses, but that's just for Python spacing, so we don't have to escape the end of the line. Okay, so this filter will be a combination of these four, and when we do this, this should filter out just for those specific events. Here we can see there's rain and thunderstorms, so it looks good so far. Now, if you have this situation where you want to test equality of a certain number of strings, then it's better to use this is-in method instead. So the way the is-in method works is that you just pass it in a list of all of the possible strings you are looking for. So in this case, we do bikes of events dot is in. So is it in one of these? So we just type them out: rain, snow, thunderstorms, and sleet, like that. And just so to show you, this should give us this type of filter. None of the first 10 have any of these events, but that's how you do this. It looks for any one of these four and returns true if the event is amongst one of those four. Now let's go ahead and just filter this out to see if we get the same thing, and looks like we do. So this is-in can work with any of the other columns, but it's typically done with strings because these are independent of one another. There are different ways, which I'll show in a future video, how to select like between two numbers. We did that above with two ands, but there is a between method for that. So this, you don't typically see this on integer or float columns, although you certainly could. You could look for a very specific trip duration of, say, 100, 1,000, and 10,000 or whatever, or specific start capacities, but it's just more common with string columns. Okay, so you can actually use this with other columns. So let's say filt1 is this, and filt2 is, let's say, we want bikes to be in one of these events, but we also want the trip duration. Let's see if any of them are greater than 5,000. So is anyone able to go for a longer ride within bad weather. And then I'll just combine the two filters here like this. So you can do this. The AND operation will occur right here, and then the final filter will be passed to the bike's data frame. So there are actually 4 rows here that meet this. Notice I didn't do .head, so these are all 4 rows. Here are the events. So only a few of these rides were longer than 5,000 seconds in this sort of bad weather. So you can do any sort of other combinations with the is/in, because this just returns a single Boolean series. So you can do as many and or and not operations with Boolean series. That's the only requirement, and there's no stopping however many other types of filters you want to add to this chain. Welcome to notebook number 7, Boolean Selection More. In this chapter, we're going to cover different types of Boolean selection that didn't neatly fit in with the other chapters. We'll begin with Boolean selection on a series. So this is possible. Boolean selection is not just for data frames, and it happens in a very similar fashion. Let's go ahead and read in the bike's data frame and set the temperature column to be this temp variable, which is going to be a series. So this is just the temperature of each bike ride as a series. In our first query, we're going to select temperatures greater than 90. So we already have a series. We don't have to select a column here. We can go straight to using the comparison operators. So let's just go ahead and do that. So we'll compare the series, every single value, against 90. And this will return a Boolean series. And we can set this equal to the variable filt. And then, as usual, we will use the square brackets. And this time it's okay to use the square brackets for using Boolean selection. And just pass in this filt Boolean series, and we should get only the bike rides, or in this case, just the temperatures that are greater than 90. Okay, so let's do a multiple condition over here. Select temperatures less than 0 or greater than 95. So here, let's just do this in one line. We'll say temp is less than 0, or use the or operator, temp is greater than 95. So we have 2 conditions separated by the pipe symbol, which is the or. So we want either very high or very low, and that's what we got. Now, one thing that we can do that'll help us with readability here is that if this index, which is coming along with the series, is not helpful whatsoever. We can actually put a column in over here that is helpful, and that is the start time. So we can see what type or what's see what part of the year it is. So let's go ahead and put in the start time column, set the index to be that, and it needs to be index underscore call like that. So that'll be the start time. So now we can see that, all right, so this temperature was recorded in June of 2013. And now we'll just run these same exact queries over here. And this should be in the summer. These are all greater than 90. So as we can see here, these are all in July. This was, I guess, a hot day in September for Chicago. And then again over here, we have the high temperatures where we're in the summer, and then the low temperatures over here are in the winter. So that can help out when you're doing a series. Make sure you get a column in there that, or make sure you set the index to something that is makes sense with the data that you are using. All right, so one other method. So instead of using, say we want to select for a specific temperature range, like between 70 and 80 degrees, well, you don't have to use an and anymore. You can actually use this between method. So the between method works by passing it the left and right endpoints, and it will be inclusive by default. So let's say we want to find temperatures between 70 degrees and 80. This will return a Boolean series, just as if you did temp is greater than 70, greater than equal to 70, and less than or equal to 80. By default, it is inclusive of 70 and 80, so it'll include 70 and 80. You can actually set this inclusive to neither left or right to change the boundaries to what you would want. So just greater than 70 or just less than 80 or both. Okay, so again, we can assign this to the filt, variable filt, and then pass in filt into the square brackets, and we'll get just those temperatures that meet this specific between condition. All right, so that is doing Boolean selection with a series. In this video, we'll cover how to do simultaneous Boolean selection of rows and column labels with loc. So we've only been using just the brackets thus far, but we can also use loc to do Boolean selection. All right, so here's our bikes data frame. And we can just keep this start time in the index for now. Okay, so before we show this simultaneous Boolean selection of rows and columns, I'll just show how you can do Boolean selection with just the rows using loc. So let's use our simple trip duration. Let's say we want trip duration is greater than, let's say 10,000 this time. We'll save that to filt. Now with loc, remember that the syntax was rows, comma, calls. All right. Now before we do rows and calls, we'll just do rows, and you can pass in filt just like this, and it's the same position with just the brackets. It's just the first position that you pass it in, and for just the brackets, it's the only position. But loc is rows, comma, calls. So this actually makes more sense with loc. It is not so ambiguous like it is with just the brackets, where the first position can select both columns with a single string or multiple columns with a list of strings. Here, filt will filter out the rows as it should. So it's not quite as overloaded as it is with just the brackets. So here I've just selected all of the rows that have rides greater than 10,000. So this is no different than just using filt like this. I should probably do it underneath. Let's do dot head over here. And then bikes, just the normal one. This will do the exact same operation. It's the same thing. Now, the reason why you'd want to use loc is if you wanted to simultaneously select some columns along with those rows. So the square brackets does not allow you to do that, but loc does. So let's say we want to do the filter, but we also want to select, let's just say the gender and trip duration and maybe the events column like that. So again, it's rows, comma, calls. So for calls, we will use a list of the strings. That's one of the possibilities, which we talked about previously. So here we have filtered out for the same rows, but we're also selecting a subset of the columns like that. So loc is really cool for doing that, and when you're doing those simultaneous row and column selection. All right, let's see one more example over here. Let's find all female riders with trip duration greater than 5,000 when it was cloudy. So we want the female rider, so say gender equals female. And we want the trip duration to be greater than 5,000. And we want to be have the events equal to cloudy like this. So this will be filt like this, and let's just wrap everything in parentheses. So we have that, and we're going to use loc at first. So works the same thing as just the brackets. So we've gotten just these particular rows that meet the condition exactly. So female greater than 5,000 when it was cloudy. Now, you may not want to see all of the data, and that's where loc comes in. Let's just say we just want to double check that the gender, trip duration, and the events are the columns that we cared about. So we're just filtering on those columns. So maybe we just want to see those 3 columns. So it becomes easier to check. And there you go. So that's how you can do simultaneous row and column selection with loc. Let's continue with column-to-column comparisons. So thus far, our comparisons have tested against a single value or just a small subset of values with is in. But you can compare one value to another value in the same position on the same row. So I call this column-to-column comparisons. So let's go ahead and look at our bikes data frame again. And let's say we want to compare this start capacity and end capacity. So we see here in this first row, this station over here has a start capacity of 11. The end capacity is 15. Over here we have a start capacity of 31 and 19 as the end capacity for that station. So what if we wanted to, let's get the start capacity, and we want to compare, let's find any rides where the start capacity is greater than the end capacity like this. So what will happen here is this is what I mean by column by column. It's going to compare 11 to 15, 31 to 19, 15 to 23, and so on. It's not just some number like 993 to 1,000, 623 to 1,000 to that same number. It's just depends on where you are in the row. Let's go ahead and create this filter, and let's verify that this is correct. So the only one where the start capacity is greater than the end capacity is the second one. So 31 greater than 19 is true. All the other ones are less. So that looks good, or equal to in this case. So now we can just pass the filter like that, and it works the same way. It just returns a Boolean series and will get you all the rows where the start capacity is greater than the end capacity. Now, one little note here is that Boolean selection does not work with iloc. So if you try to do iloc, again, it is rows comma calls. We don't have calls or rows here. We'll just use filt, and it says iLocation based Boolean index cannot use indexable as a mask. That just means it does not work with Boolean indexing like this. So you just can't you can only use loc for with a Boolean selection and not iloc. So that's just a limitation in pandas. In this video, we'll be finding missing values with isNA. So this is a new method we have not talked about. It determines whether or not a value is missing or not. So in our bikes data frame, if you recall, we called this info method before. And this info method returns the column name, the data type, and importantly, the number of non-missing values over here. So there are exactly 50,089 rows over here. So any row that has less than 50,089 non-missing means that there are some missing values in that column. Okay, so we can see here that the start capacity and end capacity each have missing values. So let's say we want to find those rows with the missing values. Well, the way to do this is with the isNA method. And so we will just get the start capacity column as a series. Okay, so we don't see any of those missing values in the very top or the end. Again, there's only a few. Looks like there's only 6, in fact. We're going to call this isNA method, which just asks each value, are you NA, true or false? If it's NA, it'll be true. If it's not, it'll be false. So most of these will be false. There'll only be a few that are true. And now that it's returned a Boolean series, we can go ahead and use this as our filter like we are now accustomed to doing. We're going to figure out where are these missing values. And we look over here, we see, okay, there's the start capacity and they are all missing. Okay, so that's how you do that. This is actually quite a helpful little method to find those missing values. All right, in some other tutorials, you might see the isNull method. So it works the same way. It's actually an alias. It's the exact same method. Pandas, this was an earlier name for the method. It works the exact same way. You can use this. The reason I like isNA is because there are other NA methods such as fillNA and so forth. So I just happen to use isNA over isNull just because it fits in with the other method names in pandas. All right, so that's how you can filter for missing values. Welcome to notebook number 8, filtering with the query method. So the query method provides an alternate way to do Boolean selection, but with more intuitive and readable syntax. You'll be filtering for specific rows that meet a specific condition. Now the reason we didn't cover the query method first is that it isn't able to do all of the selections that Boolean selection is capable of. So there's only a subset of the ways to filter a data frame that is capable with the query method, and is I actually recommend using the query method over Boolean selection whenever possible, and just falling back to Boolean selection if you cannot complete the filtering with the query method. All right, so let's get started here, and you'll see quickly how much easier the query method is. So here we've read in our bikes data set, and just to show you a very quick query, one of the simplest queries is, we'll do one here. So we're going to call the query method, and the way you use the query method is by creating a string. Now inside here is where you place your filter. So just like with Boolean selection, you're going to create a filter, but the filter will, you don't have to select the column with bikes. You can just reference the column name specifically, and then you'll use one of the 6 comparison operators, and this is for a simple query. We'll cover all the syntax in this chapter, and let's test it against, say, an integer such as 5,000. So this is your simplest query that you can make. Have one column, you use one of the comparison operators, and you test this condition against some other number. So here we're going to filter for all rows that have a trip duration greater than 5,000. Let's go ahead and do that. And just so we can see the alternative with Boolean selection, and you can see that is much nicer syntax. It's kind of just strange seeing bikes twice over here like that. So a lot of people like using the query method, and it is what I use whenever I can, and if I can't, then I fall back to Boolean selection. All right, so let's see some more of these, more usage of the query method. So again, the way it works is you can pick out a single column, let's just say temperature, and this time we'll test exact equality. Let's find all the rows that have a temperature equal to exactly 81 degrees. And you can see that there's over 1,000 rows. All of these have 81 degrees exactly, so that you can use what any of those comparison operators will work. Now let's say you want to test equality against a string, so bikes.query, and we want events to equal, let's just choose snow. And the way you do this is you have to wrap your string inside quotes. And if you use a single quote on the outside, then you have to use double quotes on the inside, or else you'll get a syntax error. If you just say snow by itself, pandas will look for a column named snow. So just characters without quotes are considered column names. And so to reference an actual string, you have to wrap it in quotes. So this will return all the columns where the event was snow. So there we go. Now, these are all single conditions. These are all pretty simple. Let's look at how we can do multiple conditions. And with query, this is very nice. You can use the strings or the character, the strings you got and, or not. I should say really like the operators and, or not inside of your query to do multiple conditions. So let's say we want gender to be female and trip duration to be greater than 5,000. So the and here works. You don't have to use the ampersand. You don't have to use the pipe symbol or the tilde. So it makes it a lot more readable. And here we go. So this is a condition where they both have to be true. All right, so trip duration greater than 5,000, gender female. We can change this to an or, so only one of them needs to be true. So we have male over here, but the trip duration is over 5,000, so that is good. Now you can use not, and be careful, not has higher precedence than or, so if you want to invert the entire condition, you'll have to use parentheses here. So if that's what we want, that's how we'll get it. So we reverse that entire condition. So that means gender is male and trip duration is less than 5,000. Okay, so yeah, so hopefully you can see that the syntax is quite a bit easier, and that's how you do multiple conditions like that. Let's move down. One kind of cool thing about query is that it allows you to do these chain comparisons. And just to show you a chain comparison in Python, so we can say 10 is less than 20. That's not the chain comparison. And 20 is less than 40. So here we have two conditions, 10 is less than 20 and 20 is less than 40. So that is true, but you might not know this. In regular Python, you can get rid of the and like this, and it will do the entire chain together. So 10 is less than 20, less than 40. That is true. So the same thing we can do with the query method. So we could say, I want the temperature between 50 and 55 degrees. So we can run this. So that's pretty cool. So it'll save you from having to do writing in an and it makes it a little bit more readable there. So all these temperatures are going to be between 50 and 55. All right, so that is a first introduction into the query method, and it's more readable syntax than Boolean selection. We'll continue with column-to-column comparisons. So this is also possible with the query method. So here, let's say we want to, instead of comparing against a single value, you can compare, say, one value with another. We did this before with Boolean selection. We're going to do it again here. So start capacity. We want all the rows where start capacity is greater than end capacity, like that. So just a column-to-column comparison. And when we do that, we're just going to get those rows where the start capacity is greater than the end capacity. So that is possible. Now let's say you want to do multiple equalities. So we want to test, say, this is usually for strings, whether one of the events is one of a number of particular events. Well, you can actually use this in operator inside of query. Do bikes.query, and we'll say events in. Now, the way you provide this is with a list. You create a list inside of here. So the syntax is a little strange because it's all wrapped inside of a string. Let's just say you want snow and thunderstorms, like that. And so that's how you would do this. And over here should just be snow and thunderstorms. So that looks good. You can actually put not in, so to do the inverse of this. So it'll give you every row that's not snow or thunderstorms, like that. And that's the vast majority. Okay, so those are a couple more things that you can do with the query method. Let's do some arithmetic operations within query. So this is actually pretty cool. The query method can do math inside. So let's say we want the start capacity to be greater than the end capacity plus, say, 20. So we want the start capacity to be at least 20 more than the end capacity. We're going to add 20 to the end capacity right here, and start capacity has to be greater than it. So let's go ahead and run this, and we should see that the start capacity should be at least 20 more. So if we go through a couple examples, we should be able to confirm that. All right, that's very cool. I'm going to show you another example that's, and this is, I'm going to read in a new data set here, how to find right triangles. And this is in the triangles CSV file. It's a very simple data set. And okay, so say we have three sides of a triangle, A, B, and C. We're going to assume these are right triangles. Sorry, we're going to filter for right triangles. So these are just sides of triangles. And we want to find which one of these is a right triangle. So each row represents a triangle, and then there are three sides. So hopefully you remember the Pythagorean theorem, a squared plus b squared equals c squared. So we're going to filter for this, and you can understand math. So we'll do a squared plus b squared equals c squared. So we're going to test equality right there. So we're going to do a whole bunch of math, and we're only going to filter for the ones where this condition is true. And then we execute that, and we can see our very famous 3, 4, 5 combination right there. And it looks like all of these are in fact right triangles. So so the query method does understand all the normal arithmetic operations that work outside of the string. In this video, you'll learn how to reference variable names with the @ symbol. So let's say we have a variable name created outside of the query method that is set equal to some value, doesn't matter. So here we have min length equals 5,000. Well, we can reference min length inside of the query method. So we say trip duration equals, and if we just write min length like this, hopefully you should know by now that this will look for a column called min length. But if we put an @ symbol here, then it will reference a variable in your scope outside of the the data frame, and it will find it and it'll equal to 5,000. So this will return well, there's none that are exactly equal to 5,000. What I should have done is say greater than or less than. So here are all the rides that are greater than 5,000. So you can reference them with this @ symbol. So that's very nice as well. Now, for this example, I'll need to use a different data set. This is the San Francisco employee compensation data set. So one limitation, and it's no longer a limitation, is that let's say you have a column that has a space in it. So like organization group or other salaries. Let's go ahead and do other salaries. Well, as you might guess, this space is going to cause a problem. So let's say we want other salaries to be greater than, I don't know, 20,000, and it says invalid syntax. So there's a space here. Now the way Python can handle this, or pandas can handle this, is that you have to wrap, if you have a column name with spaces, then you have to wrap it in these backticks. So pandas will read it in as a column name with a space. So pandas column names can have any characters including spaces, so you'll need this backtick whenever you do have one. So now when we run this, it'll correctly interpret this other salaries as a column name with spaces, and then we can see that it'll only select the ones with more than 20,000. So there's a couple more little good rules for the query method. Let's move on to selecting columns with the query method. So let's say we're doing this query right here. So we're just checking that events is either snow or rain. And we want to select these 3 columns. So first let's make the selection without doing any column selection, like this. So this is one unfortunate thing about the query method. You cannot select columns simultaneously. It'll have to happen outside or after the query method has run. So with loc, if you recall, you can simultaneously select rows and columns. This is not possible with the query method. So you have to either save this data frame to its own variable name and then just do your normal column selection, or you can do it at the same time. So here I will use the square brackets for column selection and then place my column selection, which is a list of strings like that, and then run this again, and then get the result I want with just those columns. Here is a summary of the query method. The expression in the string must evaluate as true or false for every row. That means we're creating some condition where every row is either kept or discarded. Column names may be accessed directly with their name. So we saw that. We just write out their name directly in the string. Often you can use one of the comparison operators to create a condition. This is the most common way to use the query method, with one of the comparison operators. You can use chained comparison operators to shorten some syntax. The operators and, or, and not are able or available to you, unlike with Boolean selection, to create more complex conditions. If you want to test against a literal string, then you have to surround it in quotes. You can use the in operator to test multiple equalities by providing it as a list. You can do arithmetic operations. They work just the same as they do outside of the string. Use the @ character to reference a variable name. And then if your column name has spaces in it, then surround it with backticks.
Now that you've completed the course, you can take the certification exam for selecting subsets of data. And the way to do that is you'll navigate to python.dunderdata.com. And so this website will give you access to a Jupyter Notebook, which will allow you to take this certification exam. Now, before we get to that, you need to be able to sign in to python.dunderdata.com, and you do that by having a GitHub account. So if you don't have a GitHub account, you have to navigate to github.com, make an account, and then click this button and sign in. So once you do that, you just put your username or email address here and your password, and then you can sign in and you'll get access to an account on python.dunderdata.com. So go ahead and do that, and then we'll continue on in the next video. Once you log in, you should see this screen, and you should recognize it as the Jupyter Notebook file system view. Your view will look a little bit different. There won't be all of these folders that are courses over here just yet. I'll show you how to enroll and take more courses and assignments in just a second. But I want to explain a little bit more about python.dunderdata.com. It is not just for these certification exams. There are different courses and assignments available over here. The main two are these Pandas challenges and Python challenges, which you do have access to. You can actually start here. I recommend reading the contents of this Jupyter Notebook. So let's go ahead and open that up. This will give you more knowledge about what to do on this site and how to access the material, which will always appear in a Jupyter Notebook. So let's exit out of that and come back here. So what I want you to do now is move over to the Assignments tab, and you might have a different course selected, but this is the Assignments tab is where you can get all of the assignments for all of the courses. But the first thing that you'll need to do is just select the course, and you'll have less options over here. But what we're looking for is the selecting subsets of data in Pandas course. So if we go over here, you'll see that there should be one assignment over here to fetch. I fetched a previous version of this exam. You can just ignore this. You don't have this. But what you'll do over here is come over here to the right-hand side and click on this fetch button. So that actually downloads the assignment. And you see downloaded assignments over here. And then you'll click on this, which is a Jupyter Notebook. And let's click on that. So that'll actually open up the certification exam. Once the notebook has finished loading, you can start the exam. I do want to cover a few important items before you begin. So number one is that I want you to complete this exam by yourself without the help of any other human. You can use the notes and videos for selecting subsets of data, but please do not ask any other human being for help. Now moving down here, I want you to place your name and email inside of these quotes. This is a Python code cell. You don't even have to execute it, but this is the name that will appear on your certificate, and this is the email of where it will be sent to. So if you pass the exam, you will be given a certificate of completion. Let's scroll down a little bit more. You can see that exercise 1 is down here. Now before that, there's a couple of sections. You'll be using this beer data set to answer the exercises, and here's a little bit information about that. You will probably want to read this in, so let's go ahead and do that. So here's that data set. Now, with Pandas and these certification exams, it's difficult to describe exactly what needs to be returned. So you have to return a very specific data frame or a series or something else. And instead of trying to describe that solution exactly, I've just given you the solution, and I'll show, and you can actually view the solution for every exercise using this function. So this is a very important function. Make sure you execute this, and we'll see how it's used below. You might be wondering, well, then you can just use this function in the body of the code of the function that you're writing to answer the code, but this will not work because your code is actually tested on another data set, and this is just on the original data set. So if you try to use this, you will not get credit for the exercise. Okay, so let's move down here and take a look at exercise 1. So it says return the number of rows and columns of the data frame as a tuple. So that is a pretty simple exercise. And to answer these exercises, you'll be writing your code within the body of the function. And it's very important to note that this function will be passed in the data frame, so that beer data frame. But you need to use df and not beer within the body of the code. So that's an easy mistake to make. Make sure you use df. That is the variable in the scope of this function that you need to use. So the first step is to delete the raise not implemented error and then write your solution here. Make sure to use a return statement to make sure you're returning something. Now I'm not going to show you this even though it's a pretty simple exercise. Let's just say you decided to do this, return length of df. So you need to execute this. And then now you can test your solution and then view the actual solution over here. So let's do that. View the output of your code. So we see there is 25,000. And then we have the actual solution is this over here. So we have it incorrect. And so you know that you need to make some changes over here and use some different code. You want to match this view solution. So if your solution matches that of the view solution, then you can be pretty confident that you have the right answer. Of course, it will be checked on another data set. So even if you get this right, you still have the possibility of getting the exercise wrong. Your code needs to work in general for any data set that is passed to it. Let's move on down. I want to show you a solution where we can look at some of the other solutions actually. So here you're going to be returning a series. For exercise 2, for 3, you will also be returning a series, and so forth. For exercise 4, an index. Let's go down to where you finally return a data frame. So here is a data frame that will be returned. So whatever your solution is, it needs to match the view solution over here. So once you just go ahead and there are a lot of exercises here. There's actually 53, and you'll be so make sure you answer all of them. And at the end, once you get to 53, you will be have it complete. All right. So in the next video, I will tell you how to submit your exam. Once you've completed the exam, you need to submit it. So you can't just answer all these questions and expect it to be graded. And you can't submit it from this Jupyter Notebook. So what you'll need to do is save your work, and it automatically saves every 15 seconds, so you should be okay. But you can click this little icon over here and save it, and then just exit out and go, and you'll be placed back into the Assignments tab. If you're not there, just make sure you click on Assignments, and then you'll just click Submit. And once you click Submit, then it'll come down over here. It should take a few seconds for your exam to be graded. And so once it's graded, you can press this Fetch Feedback button, and then a little link that'll provide you with your score should be provided. Let's go ahead and press the Fetch Feedback button. And what you'll see is that there will be a link that appears. It might take 10 seconds for this to work. It has to be graded. So if you just be patient, this link should appear. So you can go ahead and click on this View Feedback, and there'll be an HTML file which you can open up as a separate tab. You can see here that I didn't answer any of the questions correctly, so I scored a 0, but that's how you can see your score. There is a passing score here, and if you have gotten above that passing score, then you will be sent an email with a certificate showing that you've completed the exam and have passed it. All right, so good luck out there. Take the exam without using any other human help. Make sure you watch all the videos for selecting subsets of data that will really help you perform well on the exam. All right, so I hope you enjoy it, it is quite challenging and fairly long, and that you get a lot out of it.